Hello everybody, we're going to take a look now at solutions to the homework assigned out of section 7.3. So our first problem asks us to solve a trigonometric equation on a given interval. So I like to approach these problems in two steps. First, we find all possible solutions regardless of the interval, and then we ask of all the solutions that exist, which ones are actually in that interval. So step one, we're going to solve 4 times the sine of theta minus 2 is equal to 0. Okay, and we're going to ask what are all possible thetas. So in order to get theta by itself, first we want to undo everything that was done to it. Okay, so if you started with an angle theta, you would begin by taking the sine, then multiplying by 4, then subtracting 2. So we're going to undo those steps in that order, in the reverse that they were done. So since the last thing was subtracting 2, we're going to add 2. That gives us 4 times the sine of theta is equal to 2. Then I'm going to undo the multiplication by 4 by dividing both sides by 4. So the sine of theta is equal to 1/2. Now we have to be a bit careful. Okay, if all you did was say, well, we've taken the sine of theta, so let's take the arcsine of both sides, you could be missing some information. At this stage, I really like to rely on the unit circle approach. Okay, now the sine of theta is a y-coordinate, so I'm going to go ahead and draw y is 1/2. Now that's a horizontal line at a height of 1/2, and we're asking what are the angles corresponding to this height, and we see that there are 2 of them, this one right here and this one all the way there. So these angles, if you compare to your standard reference triangles and circles, the one in the first quadrant is pi over 6. However, the corresponding angle over in the second quadrant is pi minus pi over 6, aka 5 pi over 6. And this is just due to a symmetry argument if you don't have a reference circle in front of you. As long as you remember this angle here is pi over 6, by symmetry, this angle is just pi all the way around minus pi over 6. Okay, and that's 5 pi over 6. Now this gives us all thetas in the standard circle, but let's try to find all possible thetas. Now the sine function has a period of 2 pi, which means all possible solutions are given by pi over 6 plus 2 pi times any integer, or 5 pi over 6 plus 2 pi times any integer. And all we're doing at this point is saying, sure, we found 2 solutions, 5 pi over 6 and pi over 6, but hypothetically, instead of doing pi over 6, we could have gone all the way around 2 pi and then done another pi over 6. We could go around twice, that's 4 pi, and then another pi over 6. K is just representing the number of times we go around, and observe it could be 0. It could also be negative, if you have negative angles going around in the clockwise direction. So we found all of our solutions, and now what we're going to do is we're going to ask of all of the solutions which ones are in the interval particular to this problem. So we're trying to find thetas specifically in between 0 and 2 pi. Okay, so step 2, of all solutions, which are in the interval from 0 to 2 pi. So we could have pi over 6 plus 2 pi times an interval, and then we'd observe if k is positive, 1, 2, 3, etc., this is going to be too big. It's bigger than pi over 2. If I have an actual quantity of pi over 2's and then I add more on top of it, I'll be bigger than pi over 2. Similarly, if k is negative, then I'll be too small because I will have a negative 2 pi, and I'm only adding a little bit on top of that, so I will be less than 0, which means the only viable choice is k equals 0. Corresponding to an angle of pi over 6. That's only half of the question, though, because while pi over 6 plus 2 pi times an integer gave us some solutions, so did 5 pi over 6 plus 2 pi times an integer. So let's look at what happens to these solutions here, and it's going to be quite similar. If I have 5 pi over 6 plus 2 pi times an integer, similarly, if k is equal to 1, 2, 3, etc., this is going to be too big. It's going to be 2 pi, or 4 pi, or 6 pi, or whatever, plus more, and that's going to be too large because we're capping our solutions at 2 pi. And if k is equal to -1, -2, -3, similarly, we have a -2 pi, or -4 pi, or -6 pi, and I'm only adding a little bit less than a single pi back, and that's still going to be negative. So the only solution is k equals 0, which corresponds to 5 pi over 6 plus 0. So our two solutions are just pi over 6 and 5 pi over 6. Now, some people may be wondering, why did I go through all this effort? At the beginning, we found pi over 6 and 5 pi over 6, so why aren't we done? Well, in this problem, we would have been, because specifically theta was in between 0 and 2 pi. But if the problem had specified, find all all angles in between 0 and 6 pi, then there would have been more. We would have had to have been worried about going around possibly up to 3 times. So I like to be thorough, find all solutions, then find which ones are in the interval. So the next problem, we are supposed to solve this equation here, and we're going to proceed pretty similarly. Okay, by subtracting 9 from both sides, we get 7 times the secant of theta is equal to -14. Division by 7 gives me that the secant of theta is equal to -2. Now, this is 1 over the cosine of theta is equal to -2, and therefore the cosine of theta is equal to -1/2. This corresponds to an x-coordinate, because cosine is an x-coordinate, so in our standard reference unit circle, x equals -1/2 is this vertical line. There are two angles, one here and one all the way around here. Okay. Comparing to our reference circle, these angles are given by, let's see, cosine is -1/2, so that's going to be theta is equal to 2 pi over 3, or theta is equal to 4 pi over 3. Okay. So, all solutions will be these two angles plus any integer multiple of pi. 2 pi, excuse me, because the cosine function has period 2 pi. Now that we found all solutions, we ask what are the ones in the particular interval for this problem, and again, since theta is supposed to be in between 0 and 2 pi, as I realize it actually says strictly less than, not really going to make a difference in this particular problem. If k is 1, 2, 3, etc., I'll have 2 pi, which is as large as I'm possibly allowed to be, but then I'm adding more on top of it. So these will all be too big. And similarly, if k is negative, I'll have -2 pi, and I'm only adding back on about 1 pi for both of them. I'll still be negative, and in this problem, negative is not a viable solution, so these are too small. Pardon me. So again, k equals 0 is the only possible option for both. So our solutions are 2 pi over 3 and 4 pi over 3. So we change things up a little bit. We've got a squared in here. So 4 sine squared theta is equal to 1. That's by adding 1 to both sides. Divide by 4. And here's a really common error people would make. If I take the square root of both sides, a lot of people would say, so sine of theta is 1/2. But the square root function ignores possible negative solutions. Okay, if sine squared theta is 1/4, the sine of theta is plus or minus 1/2. So I have y, a y coordinate because of a sine, is 1/2, or y is minus 1/2. And in our standard circle, that's given by these two lines right here. So there's this angle, this angle, this angle, this angle. Okay? This is the line y equals 1/2, this is the line y equals minus 1/2. So this angle right here is pi over 6. Okay? This angle down here is negative pi over 6. This angle here is 5 pi over 6. And this angle here is negative 5 pi over 6. So we can have pi over 6 plus 2 pi times any integer. We could have minus pi over 6 plus 2 pi times any integer. We can have 5 pi over 6 plus 2 pi times any integer. And we can have minus 5 pi over 6 plus 2 pi times any integer. And now which choices of k give a theta in the interval from 0 to 2 pi. So here I have pi over 6 plus 2 pi times an integer. If I add an actual 2 pi or more, this is going to be too big. So k can't be 1 or bigger, but similarly if k is negative, I'll have taken away 2 pi and I'm only adding back in pi over 6, which is fairly small, so k can't be negative. So the only choice here is k equals 0. Here, however, notice we have a minus pi over 6. If k is 0, minus pi over 6 is actually going to be too small. K can't, the angle is not allowed to be negative. So in fact, k equals 1 gives me 2 pi minus pi over 6, which when you work out all the fractions is 11 pi over 6, and that is acceptable. Okay, 11 pi over 6 is just a little bit less than 2 pi. So k equals positive 1 is actually the only choice here. Quite similarly, here k is allowed to be only 0, and here k is only allowed to be 1. Now, I could have avoided this distinction of 0 versus 1 choice for k if instead of using this angle as negative pi over 6, instead of saying go down here, if I had said go all the way around, we would have gone directly to the angle 11 pi over 6. But in my mind, negative pi over 6 is easier to see as a small angle downwards than a very large angle going all the way around. Okay, so here we'd have k equals 0 is the only choice, here k equals 1, here k equals 0, and here k equals 1. Are the only possible choices for k that result in angles between 0 and 2 pi. So our final set of solutions is pi over 6. This works out to be 11 pi over 6, 5 pi over 6, and if k equals 1 here, you end up with 7 pi over 6. So here is our set of solutions. Okay, now what's changed up is that the angle we are taking a sine of is not theta. We're taking the sine of 2 theta. So set that aside for the moment. Okay, we still want something with a y coordinate of 1/2. Okay, and we've done several of these now, so if I draw the line y equals 1/2, we know just from having done this a few times now, we've got the angle pi over 6, and we've also got the angle 5 pi over 6. But observe, that's not theta. The thing we're taking the sine of is not theta, it's 2 theta. That's what we are taking the sine of in this expression, which means that angle can be pi over 6 plus 2 pi times any integer, or that angle can be 5 pi over 6 plus 2 pi times any integer. And now, okay, this is a really common point of confusion, but I am not taking the sine of theta. The angle we're taking the sine of is 2 theta, so that is the angle that could be any of these possible solutions. And now we can try to solve this for theta. So we get, if I divide both sides by 2, we get theta could be pi over 12 plus pi times an integer, or 5 pi over 12 plus pi times an integer. Notice the 2's have canceled out. And now we ask which k's give theta from 0 to 2 pi. So here I can't let k be negative because then I'll have taken away a pi and only added back a little back in. K equals 1 is k equals 0 is fine. I get pi over 12. K equals 1 is also fine. Pi over 12 plus pi is still in between 0 and 2 pi. Once k is 2, however, I have something positive plus 2 pi, that's too big. So in this first line, I can let k equal 0 or 1, and it's actually the same down here. Okay, for similar reasons. If I take away any quantity of pi's and then I add back less than half of a pi, that's still going to be negative. If I add 2 pi or more, it's going to be too large. But both k equals 0 and k equal 1 will give values in between 0 and 2 pi. So there are actually 4 solutions here, given by pi over 12 plus pi, 5 pi over 12, and 5 pi over 12 plus pi. Okay. You may be required to simplify these as 13 pi over 12, and this right here would be 17 pi over 12. That will sort of depend on who's grading or what computerized system is checking your work. There's not really a difference between these two answers in any legitimate sense except how they're written. Okay, the thing, however, in this problem that was new is that the angle we were taking the sine or cosine of was not just theta. We had a 2 in there, which meant there was something else to be done. Okay, so let's take a look here. So this adds one more little step. Okay, in addition to the previous obstruction that the angle wasn't just theta, it's now theta over 2 minus something. But that's fine. We ask, what are the angles for which the tangent is equal to 1? Now, if the tangent of an angle, and I'll just call it, let's see, not theta, because theta is being used for something, let's call it the tangent of capital A for angle, equals 1, then the sine of the angle over the cosine of the angle is equal to 1. In other words, the sine of the angle is equal to the cosine of the angle. So the y-coordinate is equal to the x-coordinate. So in our standard unit circle, if I draw the line y equals x, it goes right like this. And we see that there are two angles, pi over 4 and 5 pi over 4, for which the tangent is 1. So we get the following, okay? The thing I'm taking the tangent of can be pi over 4 or 5 pi over 4 plus a multiple of 2 pi, but mostly we approach tangent as only having sort of a default domain of quadrants 4 and 1 with a period of pi. So it's pi over 4 plus pi times any integer. So the period of the tangent function is not 2 pi like sine and cosine. The period of the tangent function is just pi. So having found a solution in quadrant 4 or 1, we just take that and say plus pi times any integer. And now the angle was not theta, it was in fact theta over 2 minus pi over 3 is now equal to pi over 4 plus pi times any integer. Okay, so from here I'm going to add pi over 3 to both sides. I just need to clear out some space here. And I'm going to start continuing my work up here at the top. Now if I take pi over 3 and add it to both sides, we get theta over 2 is equal to pi over 4 plus pi over 3 plus pi times any integer. This works out to be 7 pi over 12 plus pi times any integer, and that's still theta over 2, so now I multiply both sides by 2, and I got theta is 7 pi over 6 plus 2 pi times any integer. And now that we have found all possible solutions, we move on to ask which ones are in our interval. The interval in this problem is that theta should be between 0 and 2 pi. That's kind of the standard, but it's by no means the only possible interval that we could be looking in. Okay, so which k's give a theta in between 0 and 2 pi? Well, if k is negative, we've got a problem. I'll be taking away 2 whole pi's and adding back in roughly 1 pi. It'll still be negative. So if k is negative, that's bad. But clearly if k is 1, I'll have 2 whole pi here added more on. If k is 1 or larger, this is definitely too large. So k equals 0 is actually the only solution. So the only solution is theta is 7 pi over 6 plus 0. Okay, a slight change here is just that we've got some sort of quadratic expression. We have a sine squared in there, but observe that you can factor a sine theta out, leaving behind this. And at this point we'd say, well, how does something, a product of two numbers, ever equal 0? Either the first factor is 0 or the second factor is 0. Sorry, plus 1 equals 0. In other words, the sine of theta should be negative 1 over root 2, sometimes preferably written as negative root 2 over 2. Okay, solving that for sine theta. There are two possible ways that we can solve this. Either the sine of theta is 0 or the sine of theta is negative root 2 over 2. Either way, the original expression will be 0. So looking at our standard reference circle, okay, y equals 0 is just the x-axis. This gives me theta can be 0 or pi plus 2 pi times any integer, because we're dealing with a sine function. The period is 2 pi. But here, at the sine of theta is minus root 2 over 2. That's down here, and the two angles are these two, which I prefer to write this as a negative pi over 4. Or positive 5 pi over 4. plus 2 pi times any integer, because we have a period function, function with a period of 2 pi. So having found all solutions, we simply move on and ask which k work to give a theta in the interval between 0 and 2 pi. Well, if I had theta equals 0 plus 2 pi times an integer, notice that we now care how our inequalities are phrased. We have to be strictly smaller than 2 pi, so k equals 1 is too big. But k equals 0, I'm allowed to equal 0 here. So the only possible one here would be k equals 0. If theta is pi plus 2 pi times an integer, again, k equals 0 is the only solution. If k is positive, then I have 2 pi plus pi, I'm way too big. And if k is negative, I have negative 2 pi, and I'm only adding back in 1 pi, I'm too small. Okay, if theta is negative pi over 4 plus 2 pi times an integer, now 0 is actually a bad choice because that would result in negative pi over 4, which is negative, so k equals 1 is actually the only legit choice here. And if theta is 5 pi over 4 plus 2 pi times an integer, then k equals 0 is the only viable choice. Altogether, our solutions are given by 0, pi, 5 pi over 4, and let's see, minus pi over 4 plus 2 pi over 4 is 7 pi over 4. Okay, they're not written in order, but there they are. Those are the 4 solutions.